What is engineering mechanics? Engineering mechanics is the study of the forces that act on bodies and the resultant motion that those bodies experience. Discipline devoted to the solution of mechanics problems through integrated application of mathematical, scientific, and engineering principles. Mechanics, a branch of classical physics that deals with the study of the forces acting on any form of matter in the universe that either keep it in equilibrium. It means at rest or in motion. We have three branches of mechanics. Firstly is kinematics, which studies the object movement without the causes that lead to these movements. Secondly, we have the dynamics, studies the motion laws and causes that induce and change this motion. Lastly, we have statics, which studies equilibrium laws of body system. So all we know that statics deals with the equilibrium of bodies, that is those that are either at rest or move with a constant velocity. Statics, it is branch of mechanics that is concerned with the analysis of laws, which is with force and torque or moment. On physical systems in static equilibrium on which do not vary over time or components and structures are at constant velocity. For the discussion of this historical development, diba, I already gave it to you. This will be your research na nakapost sa ating Google Classroom. So you are looking for the contribution of Archimedes, Galileo and Galilei, and Isaac Newton for the historical development of the world. Dynamics is concerned with the accelerated motion of bodies. Rigid body is defined as a particular system of particles which does not deform. So we have the basic concept. So particle which is body of negligible dimensions, while for the rigid body, that is body with negligible deformations. While for the non-rigid body, that is a body which can deform. So before considering whether the body can be assumed rigid body or not, you need to estimate the relevant force first. In statics, bodies are considered rigid unless stated otherwise. Particle is a small localized object to which can be ascribed several physical or chemical properties such as volume or mass. Force is a push or pull upon an object resulting from the object's interaction with another object. It is any external effort that causes an object to undergo a certain change, either concerning its movement, direction, or geometrical construction. So, basic concept for the force, for the vector quantity that is described as an action of one body on another in statics. While in dynamics, force is an action that tends to cause acceleration of an object. For the SI unit of force, magnitude is the Newton. 1 Newton is equivalent to 1 kilogram meter per second squared. So these are the characteristics of forces. First, we have magnitude. Is the size, strength of, or quantity of a force regardless of the direction in which it acts. Secondly, we have the point of application. Precise point at which a force is applied on the body or system receiving the force. Next, we have direction, where the force will go or coming from or going through. Next, we have sense of force, resistance to pressure. This specifies the direction, positive or negative, in which the force moves along the line of action. Types of forces. First, we have applied forces transferred from a person or object to another person or object. Secondly, we have gravitational force. Large object attracts smaller objects. We have normal force exerted on an object when it is in contact with another object. For friction force, it occurs when an object moves or tries to move across and the surface opposes the object's movement. Next, we have the air resistance force act on an object as they travel through air. This force will oppose motion, but only factors in when object travels at high speed or have a large surface. Tension force. It passes through string, cables, ropes, or wires when they are being pulled in opposite direction. We have basic quantities. Length, locate position, and describe size of physical system. It also defines the distance and geometric properties of a body. For time, we have conceived a succession of events. For mass, we have comparison of action of one body against another, or measure of resistance of matter to a change in velocity. For force, push or pull exerted by one body on another occur due to direct contact between bodies or person pushing against the wall. Di ba remember, pag tinulak mo yung wall, yan, parang naglalagay ng force o nilalagay ng load. Occur through a distance without direct contact. That is what we call gravitational, electrical, and magnetic force. There are three laws of Isaac Newton's or Newton's what we call Newton's law of motion. First, we have every body of or particle contains in state of rest or a uniform motion in a straight line unless it is compelled to change the state by forces acting upon it. Yun yung tinatawag natin na law of inertia. Diba? For example, sa isang lugar, meron kang yung table. Yung table na yun, hanggat wala kang ina-apply na force, hindi gagalaw yun. Diba? Kahit anong abutin pa man siya ng taon. Pero, once na naglagay ka ng motion, matik, gagalaw naman yun. Diba? Kasi pupush mo na siya. Okay, so we have the second law, which is law of acceleration, which is the change of motion of a body is proportional to the net force imposed on the body and is in the direction of the net force. That's what we call law of acceleration or second law of motion. Next, we have the third law, which is law of interaction, which is action and reaction, or action equals reaction. If one body exerts a force on the second body, then the second body exerts a force on the first that is equal in magnitude, opposite in direction, and collinear. That's what you call the law of interaction. For example, ganito lang yan. Pag sinampal ka, ano gagawin mo? O di ba, sasampalin mo rin. Parang ganun. Automatic yun, di ba? Kumbaga, gaganti ka agad. So, that's what you call law of interaction. Okay, basic Newton's law or unit. So, all we know that unit ng force is Newton, which is 1 Newton is equivalent to 1 kilogram meter per second squared. So, makita natin dito, yung N is Newton, kg is kilogram, M is meter, S is second. Okay, so we have Newton's law of gravitational attraction. So, F is equal to G, multiplying for the M1, M2 all over R squared, where F is equal to force of gravitational between the two particles, where G is universal constant of gravitation, where M1 and M2 is the mass of two particles, where R is the distance between the two particles. So we have weight. All we know that weight is equal to mg. Pero pag chinek natin yung kanilang mga derivation, makikita natin weight is equal to mg kasi where G is G multiplying for the M all over R squared. So, yun. So we have the internal system of units, the SI unit system. We have for the length, meters, time, seconds, mass for kilogram, force is equal to Newton. Remember that speed is equal to distance over time. For US customary units, length is equivalent to foot, time, seconds, mass is slug, force is pound or slug feet per second squared. Remember, the formula is weight is equal to mg, where the value of g is 32.17 feet per second squared. Unlike sa SI, we use 9.8 meter per second squared. Ito ang gagamitin natin sa US unit. For numerical answer, remember, always use three significant figures. If digit is 1, first digit is 1, then use the next 3. Yeah, for example. For rounding off, kasi meron tayong mga rules na rounding off, di ba? Pag less than 5, ida-draft na natin yung mga kasunod. I-retain na natin. Pero, pag more than 5, mag-a-add tayo ng 1. Di ba? Parang ganun. So, pero pag if you're using a calculator, automatic na nag-round off na siya.